Okay, now we look at example 18. A movie stunt driver on a motorcycle speeds horizontally off a 50-meter high cliff. How fast must the motorcycle leave the cliff top to land on level ground below 90 meters from the base of the cliff where the camera are? Okay, so as you can see here, we have a motorcycle. So this motorcycle is 50 meters above the ground. And then what happened is this motorcycle leaves the cliff top, and then it leaves the cliff top and it lands here. And then it lands at this point 90 meters from this point here, from the base of the cliff. Okay, so basically we are given two values, which is actually the value for the displacement. This is the vertical displacement and this is the horizontal displacement, ataupun kita boleh cakap vertical is the y component 50 meter and horizontal is the x component 90 meter. Okay, so basically what the question asks is, okay, how fast must the motorcycle leave the cliff top? How fast? Maksudnya berapa kelajuan motorcycle ni untuk dia landing dekat point ni, di mana point ni dia mesti 90 meter daripada the base of the cliff. So we want to find actually the velocity. What is the velocity of the motorcycle here? So we want to find is the velocity, which is the initial velocity lah. We call it as initials because initially dia dekat sini. So what is the initial velocity of this motorcycle? Okay, so basically this one here, at this point here, situation here, we actually have angle is equal to 0. So basically at this point here, we call this as horizontal projectile, di mana angle adalah sama dengan kosong. So if the angle is equal to 0, obviously the y component is actually equal to u sin theta, right? Di mana sin kosong adalah sama dengan kosong. So obviously the y component adalah sama dengan kosong and x component is u cos 0 theta, di mana theta dekat sini adalah kosong. So dia akan jadi sama dengan 1. So basically u adalah sama dengan ux. Okay, what we want is actually basically the same thing as ux because uy adalah sama dengan kosong, so we don't have to find the magnitude. Automatic magnitude dia adalah sama dengan x component. So basically what we want is to find the ux. Okay, so now if we look here, if we look here, since we want to find is ux, right? So we want to find ux here. In order to find ux, we either need to find t or we need to find vx. Okay, mana yang paling senang adalah we need to find t because we already have the value for sx, which is given here. Kita sudah ada sx. So according to this formula, we have the value for sx. So in order to find ux, we need to find the value for t first. So value for t adalah the time taken for the whole journey all the way to here, which actually we can find using the formula for y component because we have the value for y component here. So which one we can use? It's either this one here or this one. Okay, untuk yang first vy, uy, negative gt, we cannot use this one because satu, we don't have the value for vy. So we need to find that one, which is a bit complicated, so let's not use this one. So we are going to use the second one. Sy is equal to uyt minus half gt square. Okay, so we are going to use this formula here. We need to find the value for t. Dan kita sudah ada sy dan juga uy. Uy we know that it is kosong. Then sy is this one. Okay, before we can substitute, remember, if the displacement is going, if the situation is going downward, macam ni kan, dia ke bawah. So displacement dia adalah sama dengan negatif. Okay, because direction dia adalah ke bawah. So untuk y component dia adalah negatif. So you need to be careful with that. So always include the negative value. So negative is equal to negative 50 is equal to 0 since uy adalah kosong, minus half g t square. So we can find the value for t, which is equal to 3.19 seconds. And now that we have the value for t, we can substitute here to find the value for ux. So sx is 90 ux, and then t 3.19. So ux adalah sama dengan 28.21 meter per second.